Good evening, everyone. Welcome to the day 41st of our UGC-NET Paper I class. In today's class, we are going to see about the remaining part of Unit 7, that is data interpretation. So, this is the topic we are going to cover today, graphical representation and all those things. So, without further ado, we will proceed. So, before going to see about all the graphical representation and all those things, we have to have a clear-cut idea about what is data presentation, what is data representation. So here, in general context, both the term that is data presentation and data representation are interchangeably used, but when we view it in the research point of view or the UGC-NET point of view, it is actually totally different. So data presentation refers to the process of displaying and communicating data findings effectively to an audience using various formats. So this is the final stage of data processing. So this involves the how we are going to present the data. Like now I am presenting a PPT, no? So this is the final format. Actually, you guys might know I am collecting from various websites all those things. Mostly I used to copy from those websites, and some of the things I used to rephrase for the grammatical convenience and the simplification process. And then after creating a PPT, I am going to my OneDrive, that is Office 365. Then I am designing that slide visualization into somewhat a pleasant thing, like how we are viewing it right now. So I am doing it that, then I am proceeding with the presentation for the class. So here what you are viewing, that is the final presentation. So data presentation is the final stage of data processing. So the objective of data presentation is to inform, persuade or support decision making by organizing and showcasing data. So what are the forms of data presentation? It could be descriptive, like what I am doing in the previous slide and the upcoming slides. That is, I am giving a paragraph and all those things. Then it might have some numerical values also. And then third one, it could be visual, like we are presenting PPT, but when we are going in the normal class, it would be either a board and chalk and all those things, or some might be verbal / oral. They will be just describing like many speeches given by the politicians or any leaders, that is verbal and oral. Multimedia, we are using various video slides, like right now I am using the certain slides. Since ours is a somewhat a professional class, I have not utilized the transition effects in the slides. But when you try to use the transition effects, it would be more effective when it is being presented to the larger audience. So that's how it is being done. So what it is here now, these are the forms of data presentation. Now comes data representation. So again, please note that in general context, both are one and the same, because both are being used interchangeably at many places. But in reality, both words are different. So here, data representation refers to the method of encoding or depicting raw data in a structured and understandable form. So here the same these three sentences or three phrases is there, no? Instead of providing it like this, I am using some other method or some other format to present the data in order to understand or make you guys to make use of the data very efficiently. Then that is data representation. So here data representation refers to the method of encoding or depicting raw data in a structured and understandable form. So in the upcoming slides in this PPT itself, there is one slide where I have utilized such format. When the slide comes, I will inform you guys. So next, it is primarily about how data is organized and symbolically expressed. So mainly the organization. So when I visit all those websites, they provide so many data and all those different things. Still, here I am collecting very minimal of relevant thing which could define the topic as well as not overexpose of the content. So here I am collecting very simple 3 sentences or 4 sentences from that particular topic in the particular website. So the objective of data representation is to simplify complex data using visual formats, symbols or codes for easy comprehension and analysis. So data presentation is the final presenting format. Even see here, to simply understand data representation, I am using a bar chart. So that is a big data, a very large number of data. I am simplifying it into a bar chart. Now that particular bar chart could either be presented in a laptop through Excel or a PowerPoint, or I could project on a screen, or I could take the printout and then present it in a hard copy manner. So there, what format I am presenting, that is data presentation. But how condensed the data or how simplified the data I am doing, that is data representation. So please understand the difference between data presentation and then data representation. Next, forms of data representation. See here, tabular, graphical, symbolic, code based. So in our class, we mostly used to see these two, the tabular and graphical. Also, there are certain things like you just remember our coding class, logical reasoning or mathematical reasoning, where we learned about codes and symbols, no? So that is also somewhat similar here. So I am representing certain symbol with the meaning of my own word. So like that it is being done. So the forms of data representation are tabular, graphical, symbolic and then code based. So this is the a mild comparison between data representation and data presentation. So see here, focus. Representation focuses on the encoding and structuring. Here it is communicating this particular structured data into a meaningful manner. Next, purpose is organize raw data. Here deliver insights or findings to the audience. Now this involves charts, graphs. Here this involves reports, dashboards, visualizations. So who used data representation? Statisticians or data analysts? Data presentation, the people use are researchers, educators and decision makers. Then timing in workflow. This data representation happens in the earlier stage, that is processing stage. But data presentation happens in the later stage, that is reporting or sharing stage. So understand the difference between this. Now next, coming in our syllabus, it is given as graphical representation or graphical data. But in order to, if you are going to learn about graphical data or graphical representation, you obviously have to know about the opposite side of that. So that is non-graphical representation. So non-graphical representation consists of two formats, that is tabular form, case form. So tabular form is simply a numerical data table where we present everything in a tabular format. So the tabular format could be considered as a non-graphical, but please note that in the upcoming slides you will find tabular format is also appearing on the graphical presentation. So I suppose this is the only form which appears in the both format, both non-graphical and graphical representation. So here the tabular form they are talking about is a simple table where serial number and then a name and some relevant data is being presented. Whereas in the graphical format, there will be some extra things or a large number of data would be utilized with a colorful manner. Next comes the case form. So case form is, see here, this technique is rarely used. Why? Because This is in the form of paragraphs and follows a rigid protocol to examine a limited number of variables. So everything could be or should be explained in the paragraphical manner. So that is the problem with this form. That's why it is being rarely used. So these are the two different non-graphical techniques of or non-graphical representation. Now graphical representation. So what is a graphical representation? So data which has been represented in the tabular form can be displayed in a pictorial form by using a graph. So if I am using a pie chart or bar chart or any graph, any visual representation, all those things comes under graphical representation. So GR, here they have abbreviated into GR. So GR is often more effective than presenting data in tabular form. So there are very many different types of graphical representation is there. So we will be seeing in the upcoming slides. So before entering into the different types, we have to again see here similarly in literature the words diagram, chart and graph are commonly being used interchangeably, but the meaning of these words are different. So here first, what is a diagram? So a diagram can be defined as a figure generally consisting of lines made to accompany geometrical theorem or mathematical demonstration. That's all. It is a sketch or drawing. So it has some shapes. So they have given example, a diagram of an engine. So how it would be, at what the measurement, mm or centimeter, whatever in right angle, all those things. No, so that is a diagram. Then what is a chart? A sheet exhibiting information in the tabulated or methodical form is also known as chart. So it is a graphical representation data as by lines, curves, bars. So there it would be one x-axis which will be a independent variable and then y-axis which would be a dependent variable. So we will be calculating the time frame or something x or y like that. So that is a chart. Then what is a graph? Graph is simply a diagram in the mathematical or scientific area of study. So a drawing representing the relation between a certain set of numbers and quantities is known as graph. So now you might wonder whether bar chart is chart or graph. In a way, both are same. Still, here we are connecting with a particular progression manner. But whereas chart need not to be follow a linear progression manner. It could follow a non-linear. Just imagine like that. So anything could be defined by mathematical notation. Then if it follows a linear path, it could be called as graph. If it doesn't, we can call it as chart. So this is just a mild example, not exact definition or relevant statement for that. Still, in order for you guys to remember what is the difference, you remember in such a manner, if a pattern follows a linear format, that is either increasing or decreasing or curve, so that is graph. If it doesn't follow that format, we could call it as chart. Also, for graph, there would be compulsorily see here a series of dots, lines, bars. That's all. That is one x-axis and y-axis. Whereas chart need not to be like that. Even pie chart is also there, where though we have different type of variables, still we won't definitely compose or confine it into a x and y mode. So that is the difference between chart and graph. So types of graphical representation. So in our syllabus, only I think these 5 are there. Only these 5 are there. I have added one more thing. So first is bar chart, then histograms, pie chart, table chart, line chart, and then scatter plot. So we will see what is what in the upcoming slides. So first is bar chart or bar diagram or bar graph. Everything is one and same. So see here, I have given an image here. So a bar graph is a chart that uses either vertical or horizontal bars to show comparisons among categories. So here thousands and among see the different kinds of fruits and vegetables. So they are comparing a graph in terms of thousands. So one axis of the chart shows the specific categories compared, and the other axis represents the discrete value. So some bar graphs present bars clustered in groups of more than one. So I don't know whether you guys have seen that. So there are certain bars embedded within a category, that is two bars adjacently collided with each other. So there are certain bar chart diagrams like that. So that is anything, how we are categorizing all those things, that is the thing. So this is the how bar chart will look. So then histograms. See here, the difference, bar chart and histograms more or less a similar thing, but the main difference is the gap in between them. Each bar has a gap of certain length or certain unit, but here there is no gap between them. It is more of a continuous thing. So here histogram is represented by a rectangular bar to depict frequency distribution. So here we have to connect the midlines. So that means the line will come like this and then move on. So when you form the trajectory of that particular line, you will find a different ups and downs of a curve. So the size of the class interval is represented by the width. So how big the width is, then that is the size of the class interval. The size of the frequency is represented by the height. So how the higher the bar, higher its frequency. So class boundaries intervals are important in the construction of histograms because they represent the x-axis or horizontal things. Next, and then frequencies represent the y-axis. So they simply say that a histogram is essentially an area diagram composed of series of adjacent rectangles. So here series of non-adjacent rectangles, but here series of adjacent rectangles. So that is the difference between bar chart and histograms. Now moving on to pie chart. So pie chart, it is a circular graph. So that represents the total value in the circular part of components. That is a big circle is divided into certain percentage based on the data being fed. So useful in comparing components and total value. So sometimes here in this presentation, in this bar chart, we have to go through what is what here, and then we have to compare the value, and we have to note down. See here, there are certain things very closely related. So I might not know the difference between each of them. So there is a possibility of manual error when I am looking at the data. But here see, they are while dividing itself, it shows the percentage. So that's how we can easily analyze which is larger, which is smaller, and what percentage they are holding in the whole of the circle. So data are expressed as a percentage of the total value. So the total value is equated to 360 degrees. Since a circle is a 360 degree, they are equating it to 360 degrees. Next is table chart. Like I said, no, there tabular form, that is normal tabular column where we are any table we are utilizing in any content. But see here, this has 12 into 12. This is a multiplication table, that is 12 into 12. So they have given multiple, the almost 13 columns. So they have given 13 into 13 columns. So that's how they are presenting also in a somewhat attractive manner by filling up various colors and all those things. So this is the table chart. So data is organized in rows and columns, not just simply 2 rows or 3 rows. Multiple data are being arranged in this manner. So why it is being used? It is used for exact values, large volumes of data, and base is for converting into graphs. And based on this value, I can convert the data into a graphical manner, that is charts or diagrams like that. No, so we can convert it like that. Then comes line chart. So this is the line chart, image of a line chart, where we are plotting different points, and when we are connecting it in a sequential manner, it forms a line. So a line chart is the most basic type of chart used in finance, and It is generally created by connecting a series of past recorded data together with a line. Like I said, no. So they are connecting each points through a line. So it is a style of chart that is created by connecting a series of data points together with a line. Now, why it is being done? This is mainly ideal for representing the trends over time. So when see here, mostly the nowadays some people are aware about the share market. So when they try to analyze the particular share value through the years, they get a candlestick format or a line format. Mostly line format will be used in all these formats. So this is the most common graphical representation. So the example they have given here, cricket score in each over, and here also air pollution over the years. So that's how in 1850 how much it was, like that they are calculating through the years. So this is line chart. Now scatter plot. I think in we as a scholars, while presenting or reporting our data, we might somewhat use this kind of plot, because the answer we would get could be scatter. So we are connecting. So this line is there now in scatter plot. The line should be connected or close to connected with majority of the points. So see here, there are certain points at some different point, but still they are connecting it to the closest thing without deviating in a crisscross manner. So a graph of points that shows the relationship between two variables. So this is used for checking correlation and then visualizing trends and outliers. So this is known as scatter plot. So these are the different types of plot in the graphical representation. So now comes mapping of data or data mapping. So what is mapping of data? It is the visual display of data using geographic maps to show patterns, relationships and distribution across locations such as countries, states, cities, whatever. So it involves associating data values with specific specific geographic coordinates or regions, so that the spatial patterns and trends can be interpreted effectively. So like this. So if each point could be considered a country, I can somewhat analyze the relationship between all the points through the years. So when they have given here. So in its simplest form, data mapping is about relationships. I am trying to find the relationship between two different variables or two or more different variables with each other, how they are influencing one another. So they have given some example here. One particular thing is they have given a list of people and their contact information. The list contains names, address, city, whatever, whatnot. So second information is also there, that is the list of people and their music preferences. Now with this data I can calculate that relation between, so names you just omit it, but based on names we can identify the gender to some extent. So we can identify what kind of music preference is made by the people of one particular gender, or what kind of musical preference made by one particular city. So all these things are there. Just a minute. Okay. So that's how it is being done here. Next, how we are going to calculate that. So that is another important thing. So here we are comparing and then mapping each thing with each other. So why we are doing that? The purpose of mapping of data. First is to visualize geographical patterns. Mostly where they are doing is population, rainfall and crime rates. Next, to compare regions based on specific variables. So if I am comparing crime rate with one particular region with another region, or rainfall, so like that I am comparing. Next, to analyze spatial relationships and trends. So how the trends are affecting one another, how it is going on. Next, last is to make data intuitive and accessible for decision making. So when I am mapping the data, after it is more like I am testing my hypothesis, either it is being accepted or rejected. So that's how we are doing that. So what happens there? We, after mapping the data, comes to identify about a particular relationship between two or more different variables with one another. So this is the purpose of mapping up data. Now this is the slide I have been talking about. See here, instead of explaining the each term, I have given a imagery example for each thing. So this is the types of data mapping. First is choropleth map. So what is a choropleth map means? See here, this image, this particular image, so all the states but colored in a different manner for certain thing. Let's say example of literacy rate or poverty. So the red denotes something, yellow denotes something. Gradually with each state the color might vary. Some might be darker, some might be lighter. So this kind of comparison is known as, or this kind of mapping is known as choropleth map. Next is dot distribution or dot density map, that is here. See this one, this USA thing. So based on my data collection, I have plotted the dots over the map. Then I found out this particular region has more dots when compared to this kind of region. So this is the dot distribution map. Next is heat map, that is here. See, you might have seen about the weather report, that map, no? So the redder it is danger, and bluer it is somewhat nearer, greener is safe. So from green to blue, yellow, and then it will reach red. So this is mainly in the weather forecast, that is heat map. Next is proportional symbol map, that is here. It is let's assume it is mainly done in the analyzing of earthquake. So at particular region, the larger the circle, the impact is larger. If it is smaller, then the impact is smaller. So this is the proportional symbol map here. Next, isoline or contour map, which is here. So this is somewhat similar to this map, that is heat map. Here they are also using the same that red color and all those things. What is the main difference means? They are using it in a line format. They are forming a line, or else let's assume a cyclone is coming and they are making a trajectory based on that particular line and drawing a different line. So that particular line formed, it has certain colors as well as some shapes. That is the isoline or contour map. Last is cartogram. See, cartogram, I don't know where people are using. Still, I found very important information about this. See here, this is the cartogram image. What happens here is, in all these images except the cartogram, the original geographical map doesn't change. They overlay or they impart their own data over the fixed map. But what cartogram does is, it gives color also at the same time. Based on the increasing or large amount of data, it disorients the shape of the particular geographical condition. See here, India and China is in full red. So the shape of India, China and Bangladesh is completely changed when compared to all these maps. So here cartogram not only provides a clear-cut idea on where the large whatever data is being fed, still it also changes the shape of the total map itself. That's how cartogram is working. So these are the different types of data mapping. Now data interpretation. I have kept the 2 slides from yesterday's class. So just I'm fastly repeating. So data interpretation is, it helps the researchers to categorize, manipulate and summarize the information to answer critical questions. So we are interpreting a data which we have received. That is I am having a chart. Based on the chart, I am concluding or making a decision based on that. So it assists us in making sense of facts and numbers. So this is the same thing yesterday. Now steps of data interpretation. Actually, please note this. This is applicable as a whole for data interpretation as well as our own exam. In our exam, so first we have to follow these steps to answer the data interpretation question. So what are the 4 steps? First is understanding the data. We have to first have a clear understanding on what the data is about or how they have arrived at the data. So that is the understanding of the data. Next, now I am analyzing the data analysis. They have given me a certain, for example, when I was writing, they have given the particular disease in particular countries. So based on the data, I am analyzing and arriving at certain conclusions. Now after analyzing, I am calculating and comparing the data for my question. Whatever question is being asked, I am calculating this particular data analysis and then comparing the data. At last, I am drawing conclusions, that is arriving at the conclusions which is necessary for me to answer the questions. So these are the steps for data interpretation. Now data and governance. See, governance, it is a main thing where without it we won't exist. Any peaceful country won't exist. But any country has to have certain data so that they can plan ahead in the future. The representation and presentation of data might have changed or evolved upon the successive years. Still, the need for data or the collection process of data by the government is not at all diminished. Why? Because any government has to have certain knowledge on what their subjects are about, what the people of that particular government is thinking about. So here governance refers to the processes, structures and institutions through which decisions are made, authority is exercised and services are delivered in a society. This includes policy making, implementation, regulation and accountability. So data in governance refers to the use of structured. Please note that there are in yesterday's class we have seen there are 3 types of data. Here structured data is only mainly used, and then organized and real-time information by government bodies, institutions and policy makers to formulate decisions, deliver services and monitor development. So that is how data and governance are interrelated with each other. So data governance covers all these aspects. So one is data architecture, data quality, metadata, data warehousing and business intelligence, reference and master data, documents and content, data integration and interoperability. Next, data security, data storage and operations, data modeling and design. So these are the various components of data governance. Now, see, I have not explained because, to be honest, I am trying to stick down to the syllabus of our UGC-NET. If I have to take class for each topic, it would extend into a single topic for each thing. So I have not gone through. Please, you go through the websites or else go through any Google whatever. So because if you want to learn like this, now I am sticking with the our own syllabus. I don't want to deviate from the topic. So that's why I have not put any explanation for all these things. So applications of data in governance. So where and all it is being applied. First is policy formulation. So without any data, I cannot formulate any policy. Next, public service delivery. So where there is need, the government can plan a particular kind of service for that tailorly made for that particular region of people. Next, monitoring schemes. The government has exhibited or implemented a particular scheme. Now the government has to monitor it so that they can revise or revoke that particular scheme in the upcoming years. Next is urban governance. So based on the data, because here not just urban, rural also included, still urban cities or urban places have much more interaction or close crowded interaction when compared to the rural places. That's why the proper monitoring and maintaining of any proper security is necessary. That's why data is used for urban governance. Lastly, disaster management. So wherever the, like, if weather is going to be bad in the next day, the government can well advancedly prepare for whatever the disaster is upcoming. So that's how disaster management is there. So these are the different applications of data in governance. Now these are the digital initiatives by our government, that is the Indian government. So first is Digital India, next is UIDAI, that is Aadhaar, and then see here data.gov.in. This is the free website laid down by our government where we can access our own relevant data. Then PM Gati Shakti. This is somewhat integrated with that GPS kind of thing, no, that mapping integrated somewhat like that. Then Bhuvan portal. This is run by ISRO for mapping of any weather conditions. And then Swayam and NAD has the electronic repositories of various books and all the theses. Next, DigiLocker. In one class I told you guys about DigiLocker, no, where we can just upload and save our digital format of the identity proofs. Next, Jam Trinity, and then lastly RTA Act and e-governance. So RTA Act, if we want to know any information through RTA Act, we can obtain that information to 99% maximum, not 100%. I won't say that. So 99% maximum we will get the relevant data, as well as because of this e-governance. Nowadays we need not to go to the direct e-services center for any application of community certificate, nativity, income, whatever. We can do everything with our either laptop or mobile phone itself. So these are the digital initiatives promoting data governance in India. Now there are certain ethical and legal possible considerations in this process, that is data governance. First is privacy. As I said, no, when we upload the data in the DigiLocker, there is a possibility if it is being hacked, my data, that is my own biometrical data from Aadhaar and all the bank oriented data from the PAN card and all those things could be exploited by any unknown person. So there is a risk of privacy. Next, data protection laws. Now cybercrime is one of the department in that is law, where they are implementing certain laws. Still it is not implemented in a large scale right now at the moment. So data protection, whatever the data which can be released or not released could be controlled by the government with certain laws. Here cyber security also, whatever I am doing now, so that is not having any negative influence like that. Next, digital divide. So the people who knows to use the governance, all those things, and who doesn't know to use it, automatically segregates the people who doesn't know to use the any kind of updated digital setups. Next, transparency versus surveillance. So sometimes I wonder if my phone is being hacked or stolen by some person. What are all the risky factors about me that could be used? So whenever I think of this, the only thing mostly I fear is that my own identity proofs, which I have a soft copy in my mobile phone, could be used for negative purposes. Other than that, I don't think I have that much any privacy matter in my phone. So like that, I am somewhat transparent in my activities, but at the same time, without my permission, I don't want others to intrude my privacy. So that knowingly or unknowingly, I am definitely sure that government surveils every person in certain aspects. So there is a issue of transparency versus surveillance in the data governance. So these are the ethical and legal considerations in the data governance. So that's all for today's class, and by now we have completed both chronologically and actually the 7th unit, that is unit 7, data interpretation. So these are the bibliographies. That's all. Thank you.